All right, let's look a little closer at a multiplexer. Here we have the circuit symbol for a multiplexer. This is an 8 data line multiplexer, 1 output line, 8 data lines, and 3 bits of address lines. This is the way it looks in the circuit. This is the way Logisim does a 3-bit address input. It's a little different perhaps than some, but what that is 3 bits that are going in on this bus to control the multiplexer. So if the values in the input address is 000, then line 0 will be presented to the output. None of the others are active, as you can see. And so I go down here and test each one. You'll see none of them are appearing on the output. The only one appearing on the output is line 0. If I go to line 1, then you see line 1 becomes the active one. Line 0 has no effect. Well, I have to turn that off to see it. None of the others will have any effect on the output, only line 1. Likewise, if I go to 3, it's data line 3 that has the control of the output, and so forth. So that's our standard multiplexer. It's a little nicer when we see it in a small box, and it's easier to connect into a larger circuit. It often occurs in computer development that we have an existing circuit that can be co-opted to do something else. Now, if you remember a little while ago, we did the majority function, which was not terribly difficult, kind of a messy circuit, but not very difficult. Can we use a multiplexer to do a majority function? The answer is yes. In a majority function, these are the values that we want to have a 1 appear for. These are the cases down here, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, that are the majority. All the others are minority. So if any one of these values appears here, we want a 1 to appear here. Well, that's very simple. These correspond to 3, 5, 6, and 7. So we take pin 7, we take pin 6, we take pin 5, and we take pin 3, and we join them all up together and connect them to a constant 1. All right? All the others we connect to a constant 0. So if the address lines are any of these values, a line with a 1 on it will be presented to the output. If it's not one of these values, a line with a 0 will be presented to the output, and that's what you see right now, 4 as the value of the input, and we're getting a 0 at the output. Let's put one of the numbers that is in the majority. There we go. That's 3. There's 7. How about that? And you see they're all. Now we're back to 0. So what we've done is we've taken the multiplexer and wired it up as a majority function. It's very simple. We simply find those pins that correspond to the input for which we want a 1 to be presented, and pin them to 1. All the others we pin to 0.